So in today's session, we are going to talk about the infamous chain rule. The chain rule is a very powerful tool that helps us in taking the derivative of some complicated looking functions. Complicated in the sense, so let's say we have two differentiable functions, f of x and g of x. Then the composition f of g of x, which is given by f of g of x. The question is, what will be the derivative of this particular composition function? So when we take the derivative of this composition function, what we have to do is we start with the first function, or the function f. Then we will use the method of derivative to find out f prime of g of x, and then multiply it to the derivative of the inner function, which is g of x. So this is referred to as the chain rule. Similarly, if we have three differentiable functions, let's say f of g of h, that case, this is simply f of g of h of x. So if we are to take the derivative of this particular function, then this will be, so first we'll start with the outermost function, which is the function f. So we'll take the derivative of this function with respect to x, then we multiply it to the derivative of the inner function, which is g of h of x. But then again, g of h of x is also a composition function, so we'll again have to take the chain rule. That means multiply it to the derivative of h of x. So this is how we can perform the chain rule. So let's try out this particular method. Example number 1. So let's say we have a function f of x, which is given by 7x plus 3 whole raised to the power of 8. So what we need to do is obtain the derivative of this particular function with respect to x. Now, what we will do, if we consider two functions, let's say h of x, which is given by x raised to the power of h, and g of x, which is given by 7x plus 3, then the composition of h with g, this is going to give us the function f of x, that is 7x plus 3 raised to the power of 8. So the question is, what is the derivative of this composition function? So we have derivative with respect to x of h of g of x, which is simply derivative with respect to x of h of g of x. Right. So that means we have h prime of g of x. That means we take the derivative of the outer function, which is h of g of x, and then multiply it to the derivative of g of x. So let's try to find out the derivative of this function f of x. What we will do, we will consider, so let's write it down. We have ddx of 7x plus 3 whole raised to the power of 8. So here 7x plus 3, if we consider, we make an assumption that this is behaving as x, 7x plus 3, that in that case the behavior would be similar to x raised to the power of 8. So that means here we can apply the power rule. So what is the power rule? So that will be 8 times 7x plus 3 raised to the power of 8 minus 1 multiplied to, now this was only our assumption, this is not exactly x, so this is 7x plus 3. So that means we apply the chain rule, which means multiply it to the derivative of 7x plus 3. So this is how we can apply the chain rule. Now let's complete the solution. So we have 8 times 7x plus 3 raised to the power of 8 minus 1 will be 7. So this is multiplied to derivative of 7x plus 3, and this is 7. So finally we have 8 times 7, that is 56. So we have 56 times 7x plus 3 whole raised to the power of 7. So this is the derivative of our function f of x. Let's try out another problem. So we have the function given by h of x is equals to e raised to the power of x squared. So let's try to find out the derivative with respect to x. So this will be equals to, so what we will do, we will make an assumption. If we think of x squared as the variable x, then this is simply e raised to the power of x. And what is the derivative of this exponential function? Simply the function itself. So we have e raised to the power of x squared. However, x squared was only an assumption. This is not actually x. So we need to multiply it to the derivative of x squared. So this is the change rule. Now we simply find out the value of the derivative of x squared. So this will be 2x. Oh, we have 2x times e raised to the power of x squared. So this is the derivative of our function h of x. Let's try out another problem. So we have a trigonometric function here given by g of x is equals to sine squared 5x. Now sine squared 5x can be also written as sine 5x raised to the power of 2. It's the same thing. Now if we take the derivative of g of x with respect to x, so this will be equals to now derivative of sine 5x whole squared. What we will do, we'll assume that sine 5 of x, that's equivalent to x. That in that case what we have is this x squared. So if we apply the power rule, so that will be 2 times x raised to the power of 2 minus 1. So here x is sine 5x. Now since this is not actually x, so we need to multiply it to the derivative of sine 5x. So this gives us 2 sine 5x. Now again we need to apply the chain rule. That's because we have sine 5x. We only know the formula for sine x, which is positive cosine of x. So what we'll do, again we'll assume that 5 of x is equivalent to x. That in that case this should be cosine of 5x. But since this is not actually x, so we need to again multiply it to the derivative of 5x. So what we have done here is we have applied the chain rule 2 times. First to sine 5x and then again to 5x. So finally we have 2 times sine 5x times cosine 5x multiplied to 5 is a constant, so we can pull it out. So we are left with derivative of x with respect to x, which goes to 1. So that this goes to 1. Here we can have 2 answers. What we can do is we can multiply 2 with 5, so that will be 10. Or we can get 10 sine 5x cosine of 5x, so this will be one of the answer. Or we can combine 2 sine 5x times cosine of 5x with the formula 2 times cosine of b times sine of b is equals to sine 2b. So that means we have sine of 2 times 5x, so this will be 10x. And we have the value 5 here. So this value is 5 sine 10x, or it could be also 10 times sine 5x cosine 5x. Whichever answer you choose, both of them are correct. Let's move on to the next problem. So we have a very complicated looking logarithmic function log of 2x cubed plus 3x squared plus 5. Even though it looks very difficult, but with the help of chain rule we can easily find its derivative. So we have 2x cubed plus 3x squared plus 5. What we can do, if we assume that this 2x cubed plus 3x squared plus 5 is equivalent to x, then we can apply the formula, or we can apply the derivative of log of x, which is simply 1 over x. So that means we have 1 over x. So x here is 2x cubed plus 3x squared plus 5 multiplied to, because we have to apply the chain rule here, we have ddx of the assumption, which is 2x cubed plus 3x squared plus 5. And this is a very simple derivative. I hope you were quite familiar with how to find out the derivative as quickly as possible. So this will be, we have 2 times derivative of x cubed. So x cubed will be 3x squared. So we'll get 6x squared. Plus we have 3x squared. So this will give us 6x. And derivative of 5 is a constant. So that will be 0. So this is divided by 2x cubed plus 3x squared plus 5. So this is the final value. Let's move on to the final problem. So we have to find out the derivative with respect to x of this given function, which is square root of 5 times tangent of 2x plus x. Looks extremely complicated, but with the help of chain rule, we can easily differentiate it. So first what we will do, we will rewrite the given expression as, all we have to do is convert the square root to an exponent form. So that means we have 5 times tangent of 2x plus x whole raised to the power of half. So if we now consider, or if we assume that 5 times tangent of 2x plus x is equivalent to x, so we have something of the form d dx of x raised to the power of half. So here we can apply the power rule, so that will be half times x raised to the power of half minus 1. So that means we have half multiplied to x. So our x here is the assumed value, which is 5 times tangent of 2x plus x raised to the power of half minus 1. So that is negative half. Then we need to multiply it to our assumption, because we are applying the chain rule. So we have d dx of the assumption, which was 5 times tangent of 2x plus x. Right. So now we have to find out the derivative of this particular function. So let's do that. So what we are doing, we are bringing 5 times tangent of 2x plus x to the denominator. So that will be 5 tangent 2x plus x. So we have raised to the power of positive half times. Now we'll apply the derivative to each of the two terms. So 5 is a constant, so we'll have 5 multiplied to derivative of tangent of 2x plus derivative with respect to x of x. Right. So this gives us 1 over 2 times. So now we convert the half back to its radical form. So this will be square root of 5 times tangent of 2x plus x. This is now multiplied to 5 times. So here we have tangent of 2x. So again we need to apply the chain rule. That is because we know that derivative of the tangent function, which is tangent of x, equals to secant squared x. We do not have anything for tangent of 2x. So we will assume that r2 of 2 times x is equivalent to x. That in that case, what we will get is secant square to x. But since this is not actually x, so we again need to multiply it to the derivative of our assumed value, which is 2x, plus derivative of x with respect to x. So that is always equals to 1. So we get, so we have derivative of 2x with respect to x. So this will be simply 2. 2 is a constant, so we can pull it out of the derivative, and we are left with derivative of x with respect to x, which is 1. So this is the final answer. So we can combine 5 times 2. So this will give us, so this will simply become 10. So we have 10 times secant squared 2x plus 1. So this is how we can use the chain rule to find out the value of a derivative, for even if the function is a very complicated looking function. Thank you.